Assalamualaikum and hi, so welcome back. So in this video, we'll be looking at the second learning objective from 6.1, which is to convert the units here. So there are a few terms that we're going to look at. The first one is the angular displacement. Symbol theta has been associated with it. And then angular velocity, we use symbol omega. And then we have period, capital T, frequency f, and also linear velocity. So these are the few terms that we are going to look at here. Okay, so the first thing here is the angular displacement. So when a particles move from A to B, the angle turn through theta. Okay, let me first draw and show you the A to B first. So let's say you have your object in a circle here. Your object is moving at point A initially, and then it moves to point B here. So initially it was here. It has traveled to this particular point. So your object has turned through an angle, we call it as theta. Okay, this is what we call as delta theta, which is known as the angular displacement of the particles in a certain time interval delta t. So when at point A, the t was equals to 0. So let's say after 5 seconds, it has traveled to this particular point. It has made an angle of theta, or in terms of angular displacement, this is how much it has turned. So to describe circular motion, we use angles instead of distance, because the object is making a circle here. The relationship between the length of an arc, okay, what is length of arc here is that, let me wait quickly. Length of arc is this part here. This is your length of arc, the S here. And the angular displacement theta is given that how far you have traveled in distance, which is your S here, is equals to the radius of the circle, multiply with the angular displacement. Alright, angular displacement here. So theta is measured in a radian. Okay, so the angular displacement is measured in radian, where one complete cycle here is what we call as one revolution. So one revolution means one complete cycle, and we know that one complete cycle has 360 degree, or we also know that it has 2 pi radian. Okay, if the object were to move in semicircle, we have covered a distance of pi radian. Okay, pi radian dekat sini adalah 180. So when you complete a circle here, you have completed 2 pi here. So kita ada 360 degree. Okay, this is the relationship between one complete cycle, atau kita panggil one revolution, with the degree ataupun with the term radian. So untuk angular displacement, you can have the angular displacement being described as a revolution, ataupun theta, ataupun radian. However, the SI unit yang kita guna untuk angular displacement adalah radian. Okay, unit yang kita guna untuk angular displacement adalah radian. So kalau dalam soalan dia cakap an object has moved 2 revolution, awak kena convert dia pergi radian. 1 revolution bersamaan dengan 2 pi. So kalaulah dia buat 2 revolution, berapalah dia punya radian. So you have to convert the unit. Okay, so remember the SI unit yang kita guna untuk angular displacement adalah radian. However, dia boleh juga diguna pakai ataupun disebut sebagai revolution ataupun degree. So ini adalah dia punya relationship for you to convert the unit. So next we are going to look at the angular velocity. So angular velocity here, we use the symbol omega of the particles is defined as the rate change of the angular displacement. So angular velocity adalah angular displacement dibahagi dengan massa. Okay, angular displacement dibahagi dengan massa. Dia sama sahaja macam dalam linear we had velocity. Apa equation of velocity is? Velocity is displacement over time taken. Okay, ini general equation, displacement over time taken. So bila kita jadikan dia angular velocity pula, what is going to happen here is you're going to change all the term into angular. Dia jadi angular displacement. Masa tak boleh ada di angular, masa adalah linear sahaja, satu jenis sahaja, so dia akan terus jadi time sahaja. Alright, so the symbol that we associate for angular displacement adalah omega. Omega is equals to angular displacement, kita dah tengok tadi, iaitu theta over delta t. Okay, since the unit for the angular displacement dekat sini adalah radian tadi, I've mentioned dia adalah radian, and the unit for time here is second. So your omega here, which is angular velocity, has a unit of radian per second. Angular velocity can also be stated in a revolution per second or revolution per minute. Okay, ini adalah another unit, ini common unit Sorry, let me repeat myself. Radian per second adalah SI unit ataupun common unit kita guna. So selalunya kalau soalan minta angular velocity, awak kena pastikan jawapan awak di-convert kepada radian per second lah. Unless it is mentioned in the question, dia nak unit mana. Other than that, yang general kita akan tinggalkan dalam radian per second. However, sometimes in the question, dia akan bagi angular velocity stated such as revolution per second ataupun revolution per minute. So kita kena convert dia pergi radian per second. How do you convert this revolution per second ataupun revolution per minute pergi radian per second adalah kita guna kaedah ini. Kalau dia kata 1 revolution per second, dia bersamaan dengan 2 pi radian per second. Ataupun kalau dia guna per minute, 2 pi bahagi dengan 60 minit. So contohnya adalah dekat sini. Revolution per second ini, contoh dia kata blah 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 has made 2 revolution per second. Okay, dia kata 2 revolution per second. Okay, apa obat adalah how do you convert pergi radian per second adalah kita nak unit radian per second. Okay, unit masa kamu tak ada masalah. Unit masa kamu dalam per second. Sorted. Unit kamu punya displacement ini yang bukan dalam radian. Okay, unit displacement kamu dalam revolution. Okay, so because omega adalah delta theta over delta t. Delta theta kena dalam radian, t kena dalam second. So unit second settle, unit revolution yang kamu kena tukar pergi radian. So kita dah tahu tadi, 1 revolution bersamaan dengan 2 radian. So what you do is 2 revolution, awak ada 2 revolution. So 2 kena darab dengan 2 pi. Okay, so awak boleh dapat unit awak dalam radian per second dekat sini. Kalaulah dia guna revolution per minute, contoh dia guna revolution per minute. Okey, bila dia guna revolution per minute, apa jadi adalah SI unit kita dekat sini adalah radian per second. Maksudnya, dua-dua kamu iaitu theta dan juga delta kamu bukan, theta dan juga t kamu dua-dua bukan dalam unit yang kita nak iaitu radian dan juga saat. So you have to convert the revolution into radian dan juga the minute into second. Okey, 1 minit bersamaan dengan 60 saat. Okey, 1 revolution bersamaan dengan 2 pi radian. So unit yang kita nak adalah second dan juga radian. So you're going to convert 2 revolution darab dengan 2 pi lah, bahagi dengan 60 saat itu. So now you can get the unit of revolution, radian per second. Okay, so tak kisahlah dia nak bagi berapa revolution pun, kalau dia bagi 10 revolution per second pun, 10 revolution itu darab dengan 2 pi. Sebab 1 revolution is equals to 2 pi. So if the question states that you have 10 revolution, awak kena convert dia pergi radian lah kan. So awak darablah dengan 10 kamu tadi darab dengan 2 pi untuk dapatkan unit radian. Okay, kalau dia kata 10 revolution per minute, kena bahagi dengan 60 saat. Sebab kita nak convert that per minute into second. Itu sahaja. Okay, kadang-kadang selain daripada dia akan guna term revolution per minute, dia akan guna short form. Dia akan guna RPM. RPM adalah revolution per minute ataupun RPS, revolution per second. So you must be alert. Okay. Alright. The next term dekat sini adalah period. Period adalah satu benda yang you have been constantly encountering ataupun you have already studied lah before this. The period of a circular motion is the time taken for the particles to move around a complete circle. Maksudnya satu complete cycle. So period is what we call as the time taken to complete one cycle. So masa yang diambil untuk menghabiskan satu circular motion itu. Okay, ataupun the time taken for one revolution, iaitu to complete that 2 pi ataupun 360 degree ataupun satu bulatan itu. Okay, so period dekat sini, what you do is to get the equation for period, you come up with equation from the angular velocity. Angular velocity adalah angular displacement bahagi dengan masa. Masa kita dah tahu adalah we are talking about period, iaitu for one complete revolution. So one complete revolution, satu complete cycle dekat sini, theta dia adalah sebanyak 2 pi. Okay, time dekat sini akan jadi period. Okay, so you're going to substitute omega as 2 pi over period here. So now you rearrange this, you can get the period adalah whatever the the period here is 2 pi divided by whatever the angular velocity is in the question. So selalunya dia akan bagi tahu lah. Tak perlu risau. Unit untuk period adalah second. And then we have a frequency. Frequency of a circular motion is the number of revolution per second. So maksudnya frequency pula kita nak tahu berapa banyak revolution yang awak boleh buat, berapa banyak bulatan yang awak boleh buat dalam masa 1 saat. Okay, it's the number of revolution per second. So what you do is you take your F and then you take your period, you divide to get your frequency. Untuk dapatkan frequency adalah 1 per period, because period adalah time taken for one complete cycle. So daripada situ, kalau awak ambil 1 bahagi dengan period, awak akan dapat berapa banyak pusingan awak boleh buat dalam masa 1 saat itu. And then finally is the linear velocity here, ataupun known as tangential velocity. Alright, bila kamu ada circular motion, linear velocity is directed tangential to the circular path and always perpendicular to the radius of the circular path as shown in the figure. So dotted line ini is your circular path, and this is the center of the circle, and this is your radius of the circle. Ini adalah radius kamu. Okay, so your velocity here, linear velocity iaitu V ini, is always tangential to the circle. Maksud tangential dekat sini adalah dia adalah sentiasa at the tangent of the circle. Right, and always perpendicular, dan sentiasa 90 darjah daripada radius kamu. So this is your radius. So your velocity is always 90 degree to the radius. So contoh, ini adalah radius saya. This is my radius. Okay, this is my R here. So 90 degree to the radius, saya akan ada saya punya velocity here. This is my tangential velocity ataupun linear velocity. The magnitude of linear velocity ataupun speed of an object in a circular motion is constant. Ini we have looked through this in our previous video. Okay, kita dah faham. But the direction of it is continuously changing. So as you can see in the diagram here, nilai V ini sama, cuma direction dia akan sentiasa berubah. Okay, to relate your linear velocity dengan angular velocity, sebab bila objek kamu membuat bulatan, dia akan ada dua-dua velocity. When the object is moving in a circular motion, it will have linear velocity and also angular velocity. Alright, angular velocity dia adalah omega. Okay, since the direction here is in anti-clockwise direction, maka omega kamu pun anti-clockwise direction. Itu saja. Alright, your omega here is in an anti-clockwise direction. So, macam mana nak cari omega, kita dah tengok tadi, iaitu delta theta over delta t. This is how you find your omega. So, now if you were to find your linear velocity, you can use this equation, V is equals to R omega, di mana R adalah radius of the circle, and then omega adalah the angular displacement, angular velocity here. Therefore, you can find your linear velocity. This is how you relate your linear dengan angular velocity. So, the unit here is meter per second lah. Tak ada masalah bahagian unit. Alright, itu sahaja untuk bahagian definition and also equation for these few terms yang you will encounter in your circular